Today we are going to discuss about chemical kinetics. Physical chemistry is broadly classified into two types. One is chemical kinetics and the other one is thermodynamics. Here we will be discussing about chemical kinetics. Chemical kinetics or reaction kinetics, it's a branch of physical chemistry that deals with the rate of a chemical reaction and the factors that affect the rate of a chemical reaction. The factors that affect the rate of a chemical reactions are, first thing, concentration or pressure, temperature, nature of the reactants and the catalyst. We will be studying in detail about these factors in the future classes. We just came across a new word or a new term, rate. What is rate of a chemical reaction? We all know that whenever a chemical reaction takes place, there is a change in the concentration of reactants and the concentration of products. That is, the concentration of reactant goes on decreasing and the concentration of product goes on increasing. Therefore, rate is defined as the time taken by the reactant to get converted into products, or it is also defined as the change in the concentration of reactants or change in the concentration of products in a small interval of time. As I have mentioned you earlier, whenever any chemical reaction takes place, the concentration of both reactants and products changes. So, rate is defined as the change in the concentration of reactants or change in the concentration of products in a small interval of time. Mathematically, rate is given by plus or minus dx by dt, where dx represents a small change in concentration of reactants or products and dt represents small time interval. So, rate is given by plus or minus dx by dt, where dx is a small change in the concentration of reactants or products and dt is a small interval of time. As I mentioned you earlier, whenever any chemical reaction takes place, the concentration of the reactants and products keep on changing. So, rate is defined as the small change in the concentration of reactants or concentration of products in a small time interval. And if you can see here, you have a plus sign and a minus sign. What does that signify? I have mentioned you before that whenever a chemical reaction takes place, the concentration of the reactant goes on decreasing and the concentration of the product goes on increasing. Therefore, plus indicates an increase in the concentration of products plus indicates an increase in the concentration of products and minus indicates a decrease in the concentration of reactant. So, plus indicates an increase in the concentration of product and minus indicates a decrease in the concentration of reactants. Now, we will consider a reaction. R gives P, where R is the reactant and P is the product. Now, rate for this reaction can be written as rate is equal to minus dr by dt, that is equal to plus dp by dt, where minus indicates decrease in the concentration of reactant, plus indicates increase in the concentration of products. Rate is equal to change in the concentration of reactant in a small interval of time, that is equal to change in the concentration of product in a small interval of time. It can be said as rate is equal to rate of disappearance of R, that is equal to rate of appearance of P. We all know that whenever a chemical reaction takes place, the concentration of reactant decreases and the concentration of product increases. Therefore, rate is equal to rate of disappearance of R, that is minus dR by dt, that is equal to rate of appearance of P, that is plus dP by dt. And remember, whenever anything is written in square brackets, it represents molar concentration in mole per dm cube or in mole per liter. Anything written in square brackets represents concentration in mole per dm cube or in mole per liter. Now, let us consider a general reaction of the type A moles of A plus B moles of B gives X moles of C plus Y moles of D. How to write the rate for this reaction? Rate is written as minus 1 by A. Whenever you are going to write the rate for any reaction, the coefficients are always taken as the reciprocal. And here negative sign signifies that A is the reactant, dA by dt, that is disappearance of A in a small interval of time, that will be equal to minus 1 by B. I have taken the coefficient as the reciprocal. Negative sign indicates that B is also the reactant, dB by dt, that is equal to 1 by X. The coefficient is taken as the reciprocal. Change in the concentration of product C in a small interval of time dt, and since C is the product, you will have a positive sign here, that is equal to plus, which signifies that D is also the product, 1 by Y, where Y is taken as the reciprocal. Change in the concentration of D in a small interval of time dt. Coming to the units of rate of a reaction, we all know that rate is given by dx by dt, where dx is the small change in the concentration of reactants or product and dt is a small interval of time. We all know that concentration is usually expressed in terms of mole per dm cube or mole per liter, and time is usually expressed in terms of seconds, minutes or hour. So, the unit of rate will be mole per dm cube per second or mole per dm cube per minute or mole per dm cube per hour. That is, if concentration is expressed in dm cube, it becomes mole per dm cube per second or mole per dm cube per minute or mole per dm cube per hour. Time can be expressed either in terms of seconds, minutes or hours, and concentration can be expressed in terms of mole per dm cube or mole per liter, and this might be asked for 1 mark. It's a very important thing. It can be asked for 1 mark. Rate is of 2 types. One is the average rate and the other one is the instantaneous rate. So, the average rate is the change in the concentration of reactant or product in a small interval of time. That is, when you consider a chemical reaction, the concentration of reactant and product goes on changing. So, average rate is the change in the concentration of reactants or product in a small interval of time. Example, we'll consider a reaction of the type R gives P, where R is the reactant, P is the product. Now let us assume that at time T1, let R1 be the concentration of the reactant and let P1 be the concentration of the product. At time T2, let R2 be the concentration of the reactant and P2 be the concentration of the product. Now, average rate is given by minus dr by dt, that is equal to, where dr represents the change in the concentration of reactant and the change in the concentration of the reactant is final concentration, that is R2, minus initial concentration, that is R1, by T2 minus T1. In the same way, R average can also be written as plus dP by dt, where dP represents the change in the concentration of product, dt is a small interval of time, that is equal to P2, which is the final concentration of the product, minus P1 divided by T2 minus T1, which is the time interval. Instantaneous rate. When you want to express the rate in a small time interval dt, then we consider instantaneous rate. That is, instantaneous rate is defined as the rate of a reaction at a particular moment of time. If you want to consider the rate of a reaction at that particular moment, then we consider instantaneous rate. Instantaneous rate is given by minus dr by dt, that is equal to plus dP by dt. Instantaneous rate can be determined graphically. Instantaneous rate and average rate can be calculated graphically by plotting the concentration of the reactant along y-axis and time along x-axis. How does concentration vary with time? We all know that whenever a chemical reaction takes place, the concentration of the reactant decreases. So, graphically, this is how concentration of the reactant varies with time. This is considered as the initial concentration R0, and if I want to find out the average rate, I need to consider the concentration of the reactant at two different time, that is, at time T1, let R1 be the concentration of the reactant, and at time T2, let R2 be the concentration of the reactant. Then average rate is given by minus dr by dt, where dr is the change in the concentration of the reactant, that is given by minus final concentration R2 minus R1 by T2 minus T1. In the same way, how do you find out the instantaneous rate? As we all know that instantaneous rate is the rate of reaction at a particular moment of time. To find the instantaneous rate, you are supposed to draw a tangent to this curve, and if you find out the slope of this tangent, you get the instantaneous rate. Suppose I want to find out the instantaneous rate at this time, then I need to draw a tangent to this curve. As we all know that a tangent is a line drawn to a curve which meets the curve at one and only one point. Thus the tangent drawn to this curve at this time, and if I find out the slope of this tangent, I get the instantaneous rate. Instantaneous rate is given by minus dr by dt, that is equal to the slope of the tangent, and we all know that slope is given by tan theta, that is equal to y by x. Now if I plot the concentration of product along y-axis and time along x-axis, the curve will be in this way. We all know that initially the concentration of the product will be 0. With time, the concentration of the product goes on increasing. How does the concentration of product vary with time? Can be shown graphically in this way. Now, if I want to find out the average rate, I need to find out the concentration of the product at two different times, T1 and T2. At time T1, let P1 be the concentration of the product. At time T2, let P2 be the concentration of the product. Now, average rate is given by plus dp by dt, that is equal to plus P2 minus P1 by T2 minus T1, which are found graphically. In the same way, instantaneous rate is given by the slope of the curve. So we are supposed to draw a tangent to this curve, and if I find out the slope of this tangent, I get the instantaneous rate. That is, R instantaneous is equal to plus dp by dt, that is equal to the slope of the tangent, which is given by tan theta, that is equal to y by x. Moving on to the next important topic, law of mass action. First, I'll give you the statement and then I'll explain the law. Law of mass action states that the rate of a chemical reaction at any instant of time is directly proportional to the product of active mass of the reactant at that particular instant of time. So you come across a new word here, active mass. What does this law say? It says that the rate of a chemical reaction at any instant of time depends upon the active mass of the reactant. What do you mean by active mass? Let us consider we have started a chemical reaction with the concentration of the reactant, say 10 mole per dm cube. And I have mentioned you before, whenever a chemical reaction takes place, the concentration of the reactant goes on decreasing. Let us assume after some time the concentration of the reactant decreases from 10 mole per dm cube to 6 mole per dm cube. That is, the initial concentration was 10 mole per dm cube. After some time t, the concentration has decreased to 6 mole per dm cube. Now this 6 mole per dm cube becomes the active mass. Initially the active mass was 10 mole per dm cube. After some time t, 4 mole per dm cube of the reactant has reacted. Now the leftover concentration is 6 mole per dm cube, and this 6 mole per dm cube will be the active mass, and the rate of a reaction depends upon the active mass of the reactant at that particular instant of time.
Yes, sir.
Now let us consider the reaction of the type A plus B gives product. If I apply law of mass action to this reaction, then according to law of mass action, rate of this reaction will be directly proportional to the active mass of A into active mass of B. That is, rate is directly proportional to the product of active mass of the reactants. Here the reactants are A and B, therefore the rate of the reaction depends upon the concentration of reactant A and the concentration of reactant B. If I need to remove the proportionality sign, I need to multiply by a proportionality constant, and here the proportionality constant is K, where K is a proportionality constant or it is also known as rate constant. If I consider the reaction of the type A plus B gives products, according to law of mass action, rate will be directly proportional to the active mass of reactant A and the active mass of reactant B. If I want to remove this proportionality constant, I need to multiply by some constant, and in this case the constant is K. Therefore the rate becomes rate is equal to K into active mass of A into active mass of B, where K is a proportionality constant known as rate constant. To define rate constant, we will consider the concentration of the reactant to be equal to unity or 1 mole per dm cube. When the concentration of the reactants are unity, then rate will be equal to rate constant. How do you define rate constant? Rate constant is defined as the rate of a chemical reaction when the concentration of the reactants are 1 mole per dm cube or unity. I'll just come again. Rate constant is defined as the rate of a chemical reaction when the concentration of the reactants are 1 mole per dm cube or unity. If I consider the reaction of the type A molecules of A plus B molecules of B gives product, how do I write the law of mass action for this reaction? For this reaction, law of mass action is given by rate is equal to rate constant into active mass of A raised to the power of A. In this case, the coefficients are raised to the power into concentration of B raised to the power of B. Here the coefficients are raised to the power. For these kinds of reaction, the coefficients are always raised to the power. Moving on to the next topic, rate law or rate equation. To derive rate law or rate equation, first you are supposed to perform an experiment. After performing an experiment, you will derive a mathematical expression that relates the rate of the reaction and the concentration of the reactants. That gives the rate law. How do you define rate law? It is an experimentally derived mathematical expression. It is an experimentally derived mathematical expression. As I told you, you are supposed to perform an experiment and then you will be deriving the mathematical expression that relates the rate of a reaction and the concentration of the reactant. For example, we will consider a reaction of the type A molecules of A plus B molecules of B gives products. Then how do you write the rate law? Rate law is written as rate is equal to rate constant into concentration of the reactant A to the power of X into concentration of reactant B to the power of Y. Here X and Y are experimentally determined exponents. As I mentioned you earlier, to derive rate law, you are supposed to first perform an experiment and this X and Y are obtained after performing the experiment. Molecularity of a reaction. Chemical reactions are usually classified into two types. One is the elementary reaction, the other is a complex reaction. What do you mean by elementary reaction? The reaction which occurs in a single step. The reaction that occurs in a single step is known as an elementary reaction, and the number of reactant molecules that is taking part in the elementary reaction is the molecularity of that particular reaction. For an elementary reaction, the number of reactant molecules participating in that elementary reaction gives the molecularity. A complex reaction is one which occurs in a series of steps. Complex reaction occurs in a series of steps, and the stepwise sequence of elementary reaction that convert the reactant into product is known as the mechanism of the reaction. The stepwise sequence of an elementary reaction that converts the reactant into product is called the mechanism of the reaction. And in a complex reaction, there will be many elementary steps, and all these steps do not occur at the same speed. Some steps are fast, some steps are slow, and the slowest step is called the rate determining step. That is, the rate of the complex reaction depends upon the elementary step that take place at the slowest speed or at the slowest rate, and the slowest step of the complex reaction is known as the rate determining step. That is, the slowest step determines the rate of the complex reaction, and the number of reactant molecules that is present in the rate determining step or in the slowest step gives the molecularity of a complex reaction. Molecularity of a reaction is always a whole number, and this molecularity can never be zero or it can never be a fraction. It should always be a whole number, cannot be zero or it cannot be a fraction. And the molecularity of a reaction can be easily calculated by a balanced chemical equation. If you have a balanced chemical equation, you can calculate the molecularity of any reaction, and molecularity is always invariant. Order of a reaction. To determine the order of a reaction, first you are supposed to perform an experiment. After performing an experiment, you are supposed to derive the rate law or rate equation. As I have mentioned you before, rate law or rate equation is an experimentally derived mathematical expression that relates the rate of a reaction and the concentration of the reactants. First, perform the experiment, derive the rate law, and then you will determine the order of a reaction. First, we will define the order of a reaction. Order of a reaction is defined as the sum of the powers of the concentration terms that are raised in an experimentally determined rate equation. As I told you before, perform an experiment, derive the rate law, and if you take the sum of the powers of the concentration terms, you get the order of that particular reaction. For example, consider the reaction of the type A molecules of A plus B molecules of B gives products. You are supposed to perform this experiment. After performing this experiment, you are supposed to derive the rate law. Let the rate law be rate is equal to rate constant into concentration of reactant A raised to the power of X into concentration of B raised to the power of Y, where X and Y are experimentally determined exponents. Now, if I take the sum of the powers, you get the order of this reaction. In this case, the order of the reaction will be equal to X plus Y. That is, order of a reaction is the sum of the powers of the concentration terms that are raised in an experimentally determined rate equation. In this case, the exponents are X and Y. If I take the sum of the exponents, I get the order of this reaction. Order of a reaction can even be 0 or it can even be a fraction. And order of a reaction can change. Order of a reaction, as I mentioned you before, is always determined experimentally. You are supposed to perform an experiment, derive the rate law, and then you will find out the order of a reaction. That is, it is always an experimentally determined value. Unit of rate constant. Different ordered reaction will have different unit of rate constant. In general, if I consider a reaction having nth order, for that reaction, the unit of rate will be mole to the power of 1 minus n, liter to the power of n minus 1 per second. Or if I express liter in terms of dm cube, it is mole to the power of 1 minus n, dm cube to the power of n minus 1 per second. Now, we will make a list of the unit of rate constant for different order reaction. For a zero order reaction, the unit of rate constant will be mole per liter per second. For a first order reaction, the unit of rate constant will be per second or per minute or per hour. And for a second order reaction, the unit of rate constant will be per mole, liter per second. And if you can observe here, we all know that the unit of rate of a reaction and the unit of rate constant for a zero order reaction is the same. The unit of rate of a reaction is also mole per liter per second, and the unit of rate constant for a zero order reaction is also mole per liter per second. That is, the unit of rate constant for a zero order reaction and the unit for the rate of a reaction are the same. And thus one of the most important question that can be asked for 1 mark either in the entrance exam or even in the main exam.